Hello friends, thank you for joining me at Our Future 2026. My name is Landon Schilling and I'm the founder of Sacred Soil Solutions. Today I want to talk about what it means to me to build a regenerative future and how I see building a regenerative business as the greatest leverage point that we have to make that change in the world. In a typical permaculture theme, I'm going to be starting with some big picture context building and then honing that down into more practical, hands-on, and applicable methods, mindsets, and applications that we can use in order to actually create that change in our environment and going out into our communities. To start, I'd like to talk a little bit about the historical context that we're in and just how massive that truly is. So where we are now is we're exactly 80 years after the Green Revolution, post-World War II, and this actually has immense significance to this industry and to what we're doing here. The reason for that is because the Green Revolution was a narrative of feed the world and do it by any means necessary and have a stable food supply for the Cold War. And there were a lot of noble ideas put forth there. There might have been some other ideas that were a little more insidious, but that's not what we're here to talk about per se. And the reason I bring that up is because when we look at the soil and we look at the ecosystems, the narrative that was applied during the Green Revolution was one of, we need to liquidate this principal asset in the soil and take all of that principal as profit or food in order to feed ourselves and the world. And now that we're 80 years into that process, we have fully liquidated that asset of soil life, and we now have to create a new narrative. The way that I see that narrative, to follow this analogy, is that because we have depleted that principal of assets, we now need to replenish that asset bank and then live off of the dividends that we create through that regeneration. The other reason I bring up the macroeconomic perspective is because food and forage are the only commodities, the physical commodities, that actually replenish themselves every single year using the sunlight and photosynthesis. No other physical commodity is like that, and the rest of the economy is then built on that physical commodity bank. And so that makes agriculture the only space at the bottom of the economy that can actually replenish and build from the bottom up. As a reflection of what happened in the Green Revolution, the place that we're at now is that we have really big revenue streams in the agricultural sector, but also extremely large costs associated with those revenue streams. So we have extremely small margins. And this is actually good news for a regenerator, because if we can cut those costs or mildly improve those revenues without increasing costs and can create that profit margin for farmers and growers and in our own gardens to be more efficient, then we can really see amazing benefits come through for ourselves and everyone around us. And we can lift the entire economy up from underneath. I know those are really big things to put forth, but that's why I see everybody building a regenerative business as our ultimate leverage point to make that change, because it is wide open pastures and wide open avenues to make those changes. Now I would like to share a little bit about some of the new knowledge that's come into the space in the last 10 years and what I see as those greater leverage points within those new ideas and new scientific breakthroughs that we can utilize to have our greatest effect. So the big three that I want to talk about are Rhizophagy, Redox, and then later in my talk I'm going to bring up horizontal gene transfer. But for now, we're just going to start with Rhizophagy and Redox. So if you haven't heard about Rhizophagy yet, do not be alarmed. It only broke into not even the mainstream, into any public knowledge in 2019 with Dr. James F. White's white paper. If you would like more details about the rhizophagy process, then please check out Matt's videos with Dr. James F. White on YouTube. He has 3 or 4 in there, 2 or 3 or 4 in there that are all really exceptional. So right now I'm going to give a brief summary of what rhizophagy is. If you already know what rhizophagy is, you probably don't think about it enough, in my opinion, and you are probably not utilizing it enough in your own growing practices, because the implications that it has are truly profound. So if you don't know, rhizophagy is the process by which plants eat. So at the tip of the root, if you have the growing tip, then there's more open pores right at the tip. And through those pores, the plant sends out exudates and sugars, which we already knew about. But then what happens is the microbes that feed off of those sugar packets and protein packets and all of the exudates and secretions that plants make, the plant actually sucks those microbes directly into corral systems, and they live or die internally in the plant, and the plant consumes them directly. So when I explained that to some high schoolers, they took that as intuitively obvious, and they were aghast that I told them if they go talk to any neighbor that they have, that they won't know what that is. And for us, what I want to talk about more deeply is the implications that that really has on plant physiology and our ability to obtain yields from plants. So if a plant is directly eating microbial life, that means that they're actually intaking their nitrogen components and their micronutrient components through embodied life. And this should seem intuitively obvious to us, I think, once we know about it, because that's how all of life feeds. And that's really the final link in the cycle of microbial life moving through plant, animal, human, and soil, and back into plant. This also ties into Redox, and so I'm going to explain Redox just a little bit, and then I'm going to kind of marry the two just a little. So Redox, as put forth by Olivier Houssaint, and I believe Olivier Saverio is one of the speakers today with the sensing and the redox meters, and I believe Olivier Houssaint is at least somewhat involved in the creation of the sensing. So redox is the electrical energy that is the fundamental driver of soil processes and also all of life processes. And potentially all natural systems are run by redox, but that's a little bit speculative. So where I see redox is the fundamental axiom by where we can determine whether what we're doing is actually having a net gain in our system or a net loss. Because that redox potential, or that electrical energy, is being gained or lost, is that benchmark for what we're doing. And to tie that back to rhizophagy, if we look at plants consuming living material rather than soluble nutrients, they're taking in something that's alive and moving and robust and energetic rather than something that's dead and sterile and lifeless. And that's actually embodied or quantified by having that redox potential, or that electrical energy, actually in those microbial life forms. So when we're giving our plants high energy foods, high redox potential foods through microbiology, then those plants are able to utilize that energy in themselves and then do their jobs even more robustly, because they don't have to do that base level of work that the microbial life was doing. And those two ideas, I think, are really the defining pieces, along with horizontal gene transfer, but we'll get there. Those two are the defining pieces that really take us from where we were and how we were doing things into how we can do things and have really robust and really successful practices that actually make a difference for ourselves and other people. So those ideas are really cool, and I love Rhizophagy and Redox, and I could really talk about them for way too long. But what I want to emphasize about those is not that we have the knowledge, but that we need to use the knowledge. And so scientific breakthrough doesn't do anything for us unless it's utilized. And by utilized, I mean applied in the system. So if a scientist discovers that like this one little microbe does this one little thing, in a natural systems discovery, that microbe was already doing that thing. And so we don't need to know every little piece of the puzzle to know that we need to start doing applications. A microbe is not useful to us unless we put it out into the environment and into the system where it can actually do those things. That doesn't mean we just take any microbe at any time and put it anywhere. We do need to have somewhat of a honed knowledge in order to get it there. But whether I know how rhizophagy works or my neighbor doesn't, if I give them a microbial inoculant that I know will be useful for them, they don't need to know all the details in order to have those benefits. This is why the farmer will always outlast the white lab coat. So now that we've talked about rhizophagy and redox as ideas and concepts, I'd now like to get into how I utilize those ideas in my own practices and some of the successes that I've had in doing that. The first thing that I've used that has been an amazing success in my context and climate and region is SAM consortiums. And SAM stands for symbiotic antioxidative microbes. I'd really like to first emphasize the antioxidative part. That again ties into the redox piece, because when we're looking at the interactions in redox, the balance that we're working with is that for every gain in oxygen, we lose an electron or lose energy. So when we have something that's antioxidative, those are also known as electron donors, or things that charge the redox system. One example of how that redox process works is plants are breathing out oxygen, O2, and so they're also gaining energy, and that energy gain is from the sunlight. So when we bring in the sunlight energy, that redox buffer and potential is able to push out the oxygen that it was working with in its system, and then the plant is able to bring energy into the entire larger system that we then consume. We breathe in oxygen and then breathe out CO2. So when we're breathing in this oxygen, we're actually lowering the total energy of our body. And that's why we have to eat food, or we would run out of energy. So with the SAM consortiums, they're antioxidative, and they're microbes that have been able to be paired together into stable relationships that then, when they're in the environment, have a wide array of application and use and functionality. And I'd like to share a little bit about what some of those are. So this is my SAM consortium that I brew. It is Microbe Master Mix. And it is my Southwest adapted SAM consortium. There are other SAM consortiums on the market. So I'd like to share a little bit about my garden this last year and what I did with it. So this last spring, I did not have any high quality compost, and working through Matt's coursework, I saw that what I had been doing was not working, and I knew it wasn't working because my yields were slowly diminishing every year despite adding things. And if you felt that frustration, go to Matt's coursework. I promise it helps. So I didn't have any compost that I wanted, but I still wanted to grow my garden, and I had my SAM brew, and I was like, I'm just gonna do foliar applications of this, and I'm gonna just lean into that as heavily as I can, and I'm gonna see what happens. So I planted out. I hadn't added anything to the soil. There was not a lot of great things going on. It is clay. There was a little bit of organic matter applied the year before, but I had planted an entire vegetable garden into it, so it had largely been used up, or, you know, it would seem that it would need replenishment. And it does, and now I have higher quality compost that I'll be using this year for even greater benefits. But in the context of this last year, I was pretty much entirely running off of the SAM consortium. And the results were really remarkable. The first thing I noticed is the plants were really dark and really strong. And when I started my tomato seedlings, I did not have any damping off issues whatsoever, which has typically been a moderate issue for me. I'll maybe have a fifth or a sixth of my tomatoes succumb to damping off, and I do a tomato plant sale locally, so this is out of like 900 plants. But this last year, just applying foliar applications of the SAM, there was like none. There was maybe one, but it might have been a different issue. So there was essentially no damping off issue, none of that fungal problem. And the microbiome of the consortium just took care of it. And the next thing I noticed is on my summer squash plants, I started to get some powdery mildew. And when I came and started to be even more rigorous, coming in like every 3 or 4 days with the consortium, it actually made the powdery mildew recede and nearly disappear. It was like, you could see that there was a hint of it, but the plant was fully functional, no problems, very productive plant. And then when the shield bugs came in that would normally start to decimate the squash plants, they would actually hatch on the plant when I would miss them, and then they wouldn't be able to take a bite. And let me cycle into the reasons why this is occurring with the SAM consortiums. The SAM consortium works within the Rhizophagy system, and it also contributes to the overall redox potential of the system. So when we apply the consortium, those microbes, many of them, actually live endophytically, meaning inside the plant. So they go in the root through the rhizophagy process and live inside the plant, but they can also go into the leaf and live inside of the plant. And once they're living inside the plant, they actually make up the microbiome of that plant and provide immune system function, provide nitrogen fixing functions, and a whole other host of benefits. So, and the consortium is embodied complete proteins. So when the plant is eating those complete proteins, it itself is also getting complete protein synthesis, which is part of the plant health pyramid, which is something that John Kemp has some great videos about on YouTube, so you should check those out if you've never seen those. And so level 2 is protein synthesis. And when you achieve protein synthesis, insect pressures almost entirely go away, because insects are not able to eat complete plant proteins. They only eat incomplete plant proteins like nitrates and ammonias and simple sugars that haven't been assimilated into those complete protein structures and amino acids. And so I was seeing this in real time with my plants, where a pest would show up, even like a blister beetle, and the blister beetles were like barely doing any damage to a tomato or a potato. Like normally if I saw that many on a plant and I hadn't gotten to them within like an hour, the plant would be mostly destroyed. And now I was seeing them on plants that maybe had the tiniest nibble, like they really had to work for it. And so that was some really exceptional results that I was seeing immediately. And this was all without having a robust soil system in place. This was just through foliar application. Now, I will add a caveat with the microbial successes in that I've heard John Kempf mention that microbial applications are more effective and robust in dryland situations, which I am in. I know it may not seem like it with the overcast day, but I live in northern Arizona where it's sunny over 300 days a year, and you just happen to catch me on one of the other 60 days. So I am in that dryland situation, and if you're in like the Midwest or Oregon, I still think there's a lot of amazing benefits from these SAM consortiums, but you might not see such a full throttle and holistic benefit from every angle like I'm seeing. Thinking about it now, I have seen some of my peers in more humid environments actually deal with things like anthracnose and Phytophthora and some other diseases that are more akin to humid environments. And these consortiums do help with that, because in the drylands where it's just the oxidative pressures and the heat and the dryness that kills the microbial populations, in more humid environments, synthetic fertilizers, pesticides, herbicides, those are going to create a similar kind of microbial desert. And so we really need to replenish that underlayment. And I see SAM consortiums as my first go-to in that process. I've also seen really amazing results with SAM consortiums in animal system applications. The first thing in that regard being that it makes flies go away. And this was a discovery for me. I didn't discover it. My distant neighbor locally discovered it, because I knew that the consortium would be beneficial in some capacity for smell and for reducing disease pressure in an animal pen situation with cattle and sheep, and they have their area that, and even when we scrape the manures, there's always like these residuals. And so I gave some to a friend, and I was like, hey, just try this out, spray it on some stuff, let me know what you think. I think it'll help with the smells that generally happen in these types of environments. And she came back to me a couple months later, and she was like, hey, it makes flies go away. And I was like, what do you mean, like, they go away? She was like, look. And she sent me this little video, and there was a carpet of flies across this manure. She said, I let this go for like over a week so it would build up so you could see what was going on. And it was the carpet, where they're all just buzzing, all the flies on the ground. And she comes in with this dilution of the SAM consortium and just sprays it down. And within 10, 20 seconds, all of the flies disappear. And I had to think about it for a while, and I was like, why is that happening? Like, that is a miracle, because flies are super annoying. And if you can make them go away from people that work with animals all the time, they will be so happy. And when I thought about it, it actually made complete sense because of the principles that I knew that the consortium was working with in soil and working with plants. And so this is how I think it works, is the flies are feeding and receiving chemical signals from the breakdown of the manure. So even if you scrape the manure, there's still residue. So for all intents and purposes, there's manure in the environment. And that manure starts to break down. So it's these plant proteins that were not fully digested because they left the animal. And that protein, when it breaks down, becomes nitrogenous, like nitrate and ammonia, or a carbonaceous compound like sugars and various things. And the larvae of the flies feed off of those simpler compounds because they're an insect, and insects don't eat complete proteins. And so that chemical signaling is what attracts the flies to lay larvae in those environments. And so the moment that she applied the consortium, those microbes move into place, and they eat the amino acids and they embody the amino acids, and then they starve out and eliminate the chemical signaling that those flies are picking up on. So quite literally, the moment she sprays, the flies depart. And then they just go to the next place where you haven't applied it yet. But if you apply it to your whole area, then all the flies will just go to your neighbor's horses or cows or sheep. And so I also see this being really beneficial for reducing disease pressures in animals. And I think there's a lot that needs to be explored in that department. So I wanted to put that out to everyone. That's like a really exciting development to me because flies are just so annoying. So yeah, that's SAM consortiums. The final piece I want to mention about SAM consortiums is they're not very complicated. They're primarily lactic. There's typically Bacillus subtilis in there. There's yeast, typically Cerevisiae, which is beer yeast, very common, and purple non-sulfur bacteria. There's other ones, and there's more advanced brews, like a SAM 5 has like these 5, and I don't even know all 5 of them off the top of my head. I think I mentioned at least 3 of them in the list I just gave you. But the point being, they're not very complex to brew, and they're relatively inexpensive. Most of the money is in distribution and, all of the regular business stuff like that. But there's a really strong leverage point there for you to get involved with SAM consortiums in your environment, and for you to be your local SAM guy. There's just so much potential there, and I'll get into the local business piece of it after I talk about compost. But I just wanted to put that out there, that SAMs are a really great way to go. EM1 is also a SAM, but there are other companies and, brews and related families of brews. So definitely dive into that whole world, and there's a lot of good that can be done there. So with that, I'm going to stop talking about the SAM microbes, and I'm going to talk about some compost. This is something that I've been working on for the last, I built it 4 months ago. I haven't had to do too much to it since then. This is a Johnson Su style. It's not a true Johnson Su. That's a very specific protocol, but it is inspired in that direction. The Beam, BEAM, is another name that Johnson and Su actually gave it, so the literature shows it as Beam. And what I did here is, typically they're above ground if you're familiar with Johnson Su, so you would have like a wire cage standing instead of it down in there. So I live in a dryland climate. In this context, I felt that doing it in ground and adding more tubes in order to get proper airflow, and you can see some of them collapsed, which is not completely ideal, but it is working. And the reason it's in ground is it mediates the temperature, and also I don't have to water it nearly as much because things are constantly drying out here, and that stresses out the microbial populations. So that's my pit variation of a Johnson Su, and I'm really happy with it right now. Like I said, it's only 4 months in. I just looked at it under the microscope. It's got a ton of testate amoeba, a ton of fungal activity, lots of spores. I did a fungal to bacterial test, and it came in at 3.6 fungal to 1 bacterial, which is 78% fungal. If you do the microbiometer test, that's what I got off this just yesterday. And it still has 8 months to go. So I really see Johnson Su style variations, or the precise protocol that they put forth in their white paper. Those are great things to pursue. It's a really passive way to compost. You just have to set it, make sure you have a way to moisturize it if you're not. Mine is able to be rained on. In other places where you get much more rain, you'll need to cover it, and that's where maybe in the ground would not be as useful. If you were somewhere that got 40 inches of rain, it might flood and be completely gross and disgusting. So, don't just blindly do what I'm doing. This works in a very dry environment here. And with the tubes, like you saw, that allows the passive air exchange, the gas exchange for all of the microbes to work, and you never have to move them. And so yeah, Johnson Su's are generally seen to be the most fungal dominant and the most robust. And in my opinion, once you get it in place and you put the resource investment into the tubes and your wire cage and your pallet and everything that you need, it's the least amount of work in the end, especially when you start to consider the actual results that you're getting in your actual compost. The density and the fungal density is immense. It cannot be understated. I believe Michael Stengel is speaking at this event, and hopefully he's talking about some of his Johnson Su, because his piles that I've seen under the scope have been absolutely phenomenal. So go check that out. And yeah, that is the second piece that I would emphasize. For me in my current environment, SAM plus Johnson Su style compost is the 1-2 punch for the most robust plant systems we can get. I also think that trying to achieve high fungal numbers, if we were going to pick one goal in our compost, it would be the highest fungal count we can get. Other things you would want in a compost are, of course, like diversity and predators like testate amoeba and nematodes, and a good bacterial presence, which is also present in very high fungal populated composts. But yeah, the fungal piece I think is like the number one. If you were just going to give it one quantitative analysis, I would really aim for that high fungal presence, because then when you take that little bit of compost and do a compost extract on it and apply it to acreage. I've talked to some farmers that are using 2 or 3 pounds per acre and seeing amazing results with cereal grains, similar results in many industries. And yeah, when you make that really high density compost, it just becomes way more efficient. And then if it needs to be shipped somewhere nearby or far away, that client or that customer or that person you're giving it to can just use so much less for the same result, and then you're saving on shipping cost, and you just make a much higher value product for what you're doing in that moment. So Johnson Su, definitely a way to go as well. And that brings me into what you can do and how this is really a localized movement, because nothing can compete with a localized brew or a localized compost that is then completely directly tailored to the environment that it was made in. And it's not even about anything special that any one person does with their preparation or with their compost in that area. This is what ties in to the horizontal gene transfer. So horizontal gene transfer is this idea that microbes will pass genetics back and forth amongst each other. Even if they're reproducing asexually, they'll still pass the genetics between each other. And we've known this in plant and seed genetics for a really long time, that genetics actually adapt to the environment and are a reflection of the environment. So when something is created in your local environment, the genetics of that preparation are already set and their tone is already aligned with what you have going on in your local environment. So if I get a Johnson Su from someone in Wisconsin, it's going to be great. for sure. It's so power packed with fungal, presence and all of that. If it's a high quality product, I am going to see benefits. But if you had that exact same quality of material that was made in your own environment, my speculation is that you would see just that much more of a boon to your system. And then you also save on the shipping costs, and you are helping your local economy, and you're making connections with your community, and you get the feedback of the hope and the success and the reward of those people around you in your local community really taking off with those things. And there's just no greater gift, in my opinion, than that. So go make a Johnson Sioux in your own backyard. If you don't have a backyard, get together with your community, make some Johnson Sioux type compost piles, make some SAM consortiums with your friends, get them out in those gardens. And yeah, I cannot understate just how much the localized piece is so important. And when you're watching this conference this week, you're going to see a lot of people doing tons of amazing projects at some pretty large scales or some medium scales all over the place, all over the world. It's really an amazing place to be here at this conference. But I feel like sometimes that can feel like, oh, well, where do I fit into that? I'm not going to be that big. I'm not going to be, maybe you're feeling that way, where you think, I'm not going to make 100 Johnson Sioux to make this giant company. But that's not what the world needs. What the world really needs is for everyone to be doing this in their local environment, getting into these practices, doing their little niche, their little bioregion, and you're going to have so much more strength, and you're going to have so much more effectiveness and thorough application across landscapes when you keep it a little bit smaller. You don't have to limit yourself, but we need to fill out the regeneration. We have these big picture ideas, and we have these big movers and players that have done huge projects across the entire world. But those are just dots on the map. We need to fill in all of those gaps. And that's where everybody comes in. So I really hope that something that I've shared is something that you can run with. And that you really walk away from this whole conference knowing that you do have a role to play there. So as a final piece, I want to put out there that there are a lot of low-hanging fruit to have amazing success stories in this movement and building your own regenerative business. You do not need to have the ultimate fungal webbed crazy Johnson Sioux compost to have an effect. Mine doesn't look like that. Mine has really good spore counts right now, but I know people that will look at really good spore counts and be like, dang it, I don't have the hyphal webs running through right now. I could be doing this better. But they live in a more humid environment than me. So I'm going to look at those spores and I'm going to be like, this is an amazing win. It's just harder for things to web through in this dryland climate here. So everything is that contextually based. And to get back to that low-hanging fruit concept, if you go out into your local community and you look at the products that are on the market, I think that you would be stunned and maybe aghast if you actually take those products and put them under the microscope, because people that aren't looking, people that aren't in this movement in the same way, who don't have access to these types of information yet, but still care and still are trying to make that difference and do mean well, they have some really poor products out there and they think they're really good and they sell them as premium products. And I've run into those products in my own environment. And I get this bag and it's sold as this premium product at like a pretty high price point for a little bag. And I open it and it's dry. And I'm like, oh no, what's that about? And then I take it and I put it under the microscope And it's like a ghost. It's so empty compared to like what I have going on. And what I have going on isn't even what I feel is my best yet. Like, we're all iterating and we're all improving. But my first piles are like far and away superior to these premium products. And I'm looking at these piles that I first created as like, this is the discount pile because I haven't dialed it in yet. And it could be that you sell it at that even lower price and it's just that much better than what the competition has. And it's not about denigrating any of those people's efforts by any means, because they also care or they wouldn't be in this field. That's my prayer anyway, is that they do care. But they just don't know. And so when you have a customer that buys that product and they expect amazing results and then it falls flat, that's a disappointment, one, but also then they're not going to believe in organic. They're not going to believe in those natural products. They're not going to believe in the microbiology because somebody told them this bag has tons of microbiology and then it didn't. So that's already going on in your local community. And you can make a simple windrow or a simple Johnson Sioux, and you can just keep the moisture consistent and the ratios in proper alignment and tend to it just a little bit. And you can be not this much better, but this much better. So please, like, do get started. Do know that you have a place in this movement. And we all have that role to play. One last thing in the low-hanging fruit category is there are connections that we just, even those of us that are fairly well versed in the space now and in the information, we just miss things that would be fairly simple when you come back to it. One example that I had when going through Regenerative Soil, Matt's course, is I was reading his book, and first he talked about some SAM consortiums, and then he gets into some Korean natural farming preps, which I also think are great. IMO is just harder to collect around here, so I'm not as involved with Korean natural farming preps personally, but I see a lot of use there. So even though I didn't touch on those in depth, those are also great. But what I saw was that I was reading about Oriental Herbal Nutrients, OHN, and in the book it says it doesn't seem to have very many negative effects on the positive biology, but it really helps tamp down on the negative biology. And my brain just went, oh, so he's saying you mix OHN in a SAM consortium in order to have more of a disease-reducing pressure on your plants. And I just thought, like, he had already thought of that and was, like, mildly insinuating that in the book. Well, then I go to class and I say, oh yeah, I've been using my SAM consortium plus OHN. And Matt himself was like, that's a great idea. And to me, I was like, how did that not come around yet? And, that's what I'm trying to show there is those easy little connections that we're just like passing right over right now. There's so many more of those, like way too many. Matt talks about this too. He talks about when he was going to write Regenerative Soil, he just felt like it was sitting out there in the field. And he was like, someone needs to go pick it up. So he just went over and he just picked it up and he called it Regenerative Soil and he wrote the book and it was a great success. And we're converging on this knowledge that's true about nature itself. And we all have our own perspective as we all converge towards that. And so we need you. We need that. And we need those thought processes. And you're going to find things that seem so obvious and so simple to you that no one else ever thought of, because that's how wide open these pastures are. That's how much possibility exists in this space now. So that's all I have on that. I'm super excited that you got through my whole video. Thank you for joining us at Our Future. I'm so excited for more to come. If you want to contact me, I have a Skool community That's the best place to reach me. I put all my social media posts on there. I'm also on Facebook on a personal level. My business has a Facebook and Instagram that are not developed yet, so you won't really find much there yet. But go to my Skool community, reach out to me there. I'd love to talk about SAM consortiums or Johnson Sioux or Rhizophagy or Redox or anything in between. I love to hash it out with different members of the community. I'd love to hear from you there. And yeah, thank you so much. Thank you for watching my video, and I look forward to so much more. Have a great rest of your conference.